2008 AP Calculus AB free response question number 1. Let R be the region bounded by the graphs of y equals sine pi x and y equals x cubed minus 4x, as shown in the figure above. So before we look at the questions, we want to find out which function matches to which line on the graph. So we see here this top one runs through 1, 0. So we can just take one function and test in the value. So y equals sine pi, we can plug in 1 for x, so we get y equals sine pi, y equals 0. So that matches, meaning this function is this top line here, and then this function will be this bottom one here. Okay, so first question, find the area of R. To find the area, all we need to do is just use A equals, A for area, A equals integral from A to B of the top function minus the bottom function. A to B are the intersection points of the two functions. Usually you would have to set the two functions equal to each other, so that would be sine pi x equals x cubed minus 4x. But just by looking at the figure, we could see that A is equal to 0 and B is equal to 2. And this top function, the sine, is going to be the top. This bottom function, the x cubed, is going to be the bottom. So when we write this in, it would be A equals 0 to 2 sine pi x minus x cubed minus 4x dx. And since this is a calculator active section, we can use a calculator to solve this. So I'll pull that up. So to do integrals on calculator, you go to math, you scroll down until you find the fn int for integral, and the first thing you're gonna put in is the inside argument here, this one. So sine pi x minus x cubed minus 4x, and then you're going to put in a comma, and then you're going to put in x, that's the dx part, that's the variable integration, and then you're going to put another comma, and you're going to put the first limit, which is a, and we said that was 0, then comma, the second limit, which is b, and that's 2. You're going to finish that with the parentheses and hit enter. And we get 4. So the area of R, the shaded region, is equal to 4. So on to the next question, part B. The horizontal line y equals -2 splits the region R into two parts. Write, but do not evaluate an integral expression for the area of the part of R that is below this horizontal line. So we have a horizontal line here, and we're trying to find the area of this region right here. To do this, we can use this again. Area equals the integral from A to B of the top minus the bottom. But this time, instead of the sine function being the top, this y minus 2 line is going to be the top, and this x cubed minus 4x is going to be the bottom again. But now we have different a and b values. A and b aren't going to be 0 and 2 this time. So we need to find these new intersection points, and the way we can do this is we use the graphing calculator. So I'll put that up. And what we're going to do is we're going to go to y equals, and we're going to plug in our functions. So y equals -2, and y equals x cubed minus 4x. Hit graph. And it's kind of small, so we can zoom in. Hit zoom, and then you move your cursor to about the area you want to zoom in on. You hit enter. And then let's find A first, this point right here. So to do that, we'll hit second trace, and we'll scroll down to intersect. And then you're going to move your cursor to about the place where you think the two lines intersect. You hit enter, enter again, enter again. And then we get that this value A is equal to 0.539. A equals 0.539. I'm going to put ... so it signifies that we have the exact value, since this by itself would just be a rounded value. And then to find the next point, to find B, we're going to hit second trace, go down the intersect, and then we'll just move the cursor over to the right Out here, enter, enter, enter. And then we get that b equals 1.675. 1.675 dot 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 for the exact value. So now we can just plug everything in. A equals integral from a to b. It's important that we have this written on the side, so we can just leave it in terms of variables over here. The top, which is -2, minus the bottom, which is x cubed minus 4x dx. And there's your integral expression. So on to the next question, part C. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of the solid. So perpendicular to the x-axis is also important. So to visualize, if this is our y-axis, this is our x-axis, and this is, say, the z-axis, and this is our region R, then you would be having squares coming out of it like this. You see here it's perpendicular to the x-axis, so it shows up like this, and so on and so forth. So you get more and more squares. So what we're trying to find is the volume of an infinite amount of these cross-section slices put together. Now to do that, simply volume equals the integral from a to b. A to b is the intersection points. The integral from a to b of the area of one slice of the cross-section. So what is the area? It tells us here that the shape of our cross-section is a square, and the area of a square is the side length squared. And by looking at this visualization, we know that this is our side length, and transfer it over to the figure. This is what we want our side length to be. And from that we can see that the side length is the top function minus the bottom function. So that would be area equals, let's keep that in green, area equals sine pi x minus x cubed minus 4x squared. So this is the area. And we just move this over into here. So v equals the integral from 0 to 2 of sine pi x minus x cubed minus 4x squared dx. And then to find this, we just plug this into the graphing calculator. So we go to math, fint, we're going to put in what we wrote there, so sine pi x minus x to the third minus, 4x squared. And then comma, then x, then 0, 2, parentheses, enter. And then we get that the volume is 9.987. We want to round to 3 decimal places for the AP exam. So V equals 9.987. Is that right? Yeah, 978. Now on to the last question in part D. The region R models the surface of a small pond. At all points in R at a distance x from the y-axis, the depth of water is given by h of x equals 3 minus x. Find the volume of water in the pond. So we think of the region R as the surface of our pond, then the depth is the function h of x equals 3 minus x. And again, we can think of this as slices of a cross-section. So to find the volume equals, and our limits are 0 to 2. The integral from 0 to 2 of the area of the cross-section, dx, and we can think of the area as the base times the height. So if the region R is our base, the depth would be our height. So V equals integral from 0 to 2 of sine pi x minus x cubed minus 4x. Remember, this is just from the top minus the bottom to find the area. then times the depth function, so 3 minus x dx. So this is our integrand, and if we take a look at the calculator, because by now you should know how to plug this in, the answer is 8.370. V equals 8.370. For more FRQ practice on area using integrals and cross-section volumes, you can check out the past FRQ questions released by College Board. So the one from 2010, number 4, part A and C is a good one. Also, the FRQ from 2013, number 5, part A and C as well.